All right, everybody, welcome to the video here for lesson number 5 on the similar triangle proofs. This is the first of 2 proof lessons that we'll do. All right, we'll do the second one a little bit later in the chapter. So for this first question, it's just asking us to explain why the 2 triangles are similar to each other. So if you notice, we have a set of sides here. If I was to reflect this bigger triangle over this imaginary line that's not here, which we could call line L, and then dilate it by a scale factor less than 1, I could potentially make it so that triangle GSR is on top of triangle ATR. Now that would make it so that GR lands on top of AR and SR lands on top of RT. So if we could see if that's the same ratio, then we know that that set of sides is a set of corresponding sides that are in the same ratio or proportional to each other. And if you noticed, we have this congruent angle in between them, so then we could say that these 2 triangles are similar by the side angle side similarity relationship. So the first thing I have to do is set up a proportion. So I have to say 36 becomes 15, and we want to see if that's equal to the ratio between 45 and 18. So if we do a quick cross multiplication here, let me just grab my calculator so we don't make any mistakes. If we do 36 times 18, we get 648. And if we do 15 times 45, we get 675. So because these 2 ratios are not equivalent to each other, even if I was to like simplify them, I'd get like 2.4 and 2.5 or something like that, we can actually say that triangle ART is not similar to triangle GRS. All right, so moving along, let's go look at our next problem here. So this is an actual proof. So this kind of combines what we did in chapter 4 with what we're doing now. So it says in the triangle AE and FG are parallel to each other. So these 2 segments are parallel to each other. So right away I should notice that angle 2 and angle 3 are congruent because of corresponding angles. It also says that this whole shape is a rectangle. Because this whole shape is a rectangle, I also know angles 1 and angles 2 are congruent because of alternate interior angles, because CD and AB are parallel to each other. So that's giving us one set of congruent angles in the 2 triangles that I want to prove are congruent. The other set of congruent angles are angle D and angle B. Because it's a rectangle, I know I have right angles. Therefore, I have the angle-angle proof postulate. So what we could first start by saying here is our first given. So AE is parallel to FG. That's given. Which then tells us that angle 2 is congruent to angle 3 because of corresponding angles. I could then also say that ABCD is a rectangle. That's given. And there's going to be 2 things that we know from that bubble. So I'm going to be able to say CD and AB are parallel because in a parallelogram, opposite sides are parallel. And from that, I was able to say angles 1 and 2 are congruent by alternate interior angles. And then one of the things that we used in previous chapters was if I know a bunch of different things are all the same, and I want to just show 2 of them are the same, I used the rule of substitution. So then by that, I could say angle 1 is congruent to angle 3 by substitution. All right, so I have one set of angles. Now the other set of angles comes from the angles here being congruent. So we can say angle B is congruent to angle D because in a rectangle, all angles are congruent. I don't even have to say they're right angles. I just need to know that they're congruent to each other. So now I have two sets of congruent triangles, so then I can say triangle DEA is similar to triangle BFG by angle. Now, I know in your last quiz I didn't put any proofs on it, but you will see that on the unit test, so just be aware of that. Yeah, I could kind of throw anything at you there, okay? So let's move on to lesson number 6. So lesson number 6, we talked a little bit more about the proportions in these triangles, and we talked about how we could kind of split them up a little bit. So the first thing I had you do here in class was I had you do the on your own exercises towards the end, right? So looking at these triangles, you just had to try and figure out what the relationships were, right? So looking at this first example, I see that I'm comparing this whole length of x, and then I can say this is like x minus 25 in the small triangle. This whole piece would then be 9, because 15 plus 9 makes back to 24. So then I can compare my corresponding parts. So my fraction should be 9 over 24 is equal to x over x minus 25. Now, this is not the only fraction you could have gotten here, just the one I'm going to use. So if we do some cross multiplying, I get 24x equals 9x minus 225. All right, notice I'm multiplying the 9 both by the x and the 25 there. If you subtract the 9x to the other side, I get 15x is equal to 225 negative. And I actually just caught my mistake here. I had this fraction upside down. So always check here as you're going. I was going to get a negative number there. That's how I knew that was wrong. So for this fraction, I actually wanted to do x minus 25 over x, small side to long side. Essentially, if you were to redraw it, like I said to do in class, it'd be easier to see, right? I'd be comparing the same sides. So then let's cross multiply. So I have 9x equals 24x minus 225. No, 24 times 25, which I need my calculator for, 600. Subtract the 24x to the other side, and I get negative 15x is equal to negative 600. If you then divide negative 600 by 15, I get an x value here, 600 divided by 15, of 40. So there's your answer. For the next one, you'll notice that the longer side here is x plus 15. So then this shorter side is 10. So looking at your separate triangles, I could say 10 is in the short or the small triangle, 12 is in the big triangle, 15 is in the small triangle, x plus 15 is in the long triangle. Again, by redrawing the triangles, it'll be a little bit easier to see. I'll do that with the homework questions. So now if we cross multiply, I get 10x plus 150 is equal to 12 times 15 180. Do some solving here. The algebra, I'm hoping, is not your problem. If it is, come and see me. And we get x equals 3, which makes sense if you look at the numbers, right? The next one, we didn't have to do any of the subtraction or anything weird like that. So I have a short side of 5x compares to a longer side of 45, the same way that the short side of 20 compares to 36. Do some cross multiplying. 5x times 36 is 180x. That becomes 900. Divide 180. And you get x equals whatever that comes out to be. Again, use your calculators here. If you didn't notice from this lesson, your calculator is going to be essentially necessary as we move forward in this chapter. The other thing is in the next chapter, it's going to be absolutely necessary. So make sure if you haven't, if you don't know where it is, all right, try and find it. So for number 40, first thing I notice there is that's 20. If I find the length of the big side here, 3x minus 5 plus 10 becomes 3x plus 5, right? Add the negative 5 and the 10 together. So then 20 becomes 28 as we dilate it. 3x minus 5 becomes 3x plus 5 when we dilate it. Do some cross multiplying. 20 times 3x plus 5 is 60x plus 100. 28 times 3x minus 5. So again, use your calculators here. So 28 times 3 is 84x minus 140. Now we want to get it so that the x's stay positive. So I'm going to move the 60 over to the other side. Having a positive x just kind of makes everything easier, which would make me have to move the 140 to the other side. Yes, you could do all that in one step. All right. So then we have 240 is equal to 24x divided by 24, and x is equal to 10. Hopefully you got all those right in the OYO questions from class. So let's take a look at the homework. So homework's just 2 questions here, right? I'll redraw the problems here for you, or the triangles for you. So it says, which measurements here are justifying that these 2 triangles are similar? So all we're trying to do is figure out which of these is going to be a set of proportional segments, right? So notice it's comparing all of the same things. So if I redraw my triangles here, so if I have triangle A, D, E, and the bigger triangle A, B, C. So it says AD is 3, AB is 6, so I would have doubled to get from one to the other. AE is 4, and AC is 12. Notice that would not be the same proportion. 3 times 2 makes 6, but 4 times 3 makes 12. So A doesn't work. So if I redraw or erase for the next one, so AD is 5, AB is 8, AE is 7, and AC is 10. So for that, I might have to do some calculator work, because I don't know what multiplies by 5 to make 8. So if I do 5 divided by 8, I get 0.625, right? So to go from 5 to 8, I get 0.625. If I do 7 divided by 10, I get 0.7. So again, not the same ratio, right? It's not the same multiplier. So that one's not right either. AD is 3, AB is 9, so multiply by 3. AE is 5, AC is 10, multiply by 2, right? 3 times 3 makes 9, 5 times 2 makes 10. Again, not right. By default, it must be D, but let's check it just to make sure that we did this right. So we go from 2 to 6, that's multiplied by 3, 5 to 15, that's multiplied by 3, so we're good. So here is your ratio times 3. Here is your ratio times 3. So we're just kind of playing with the numbers here. This was a Regents question. You could probably tell by the different typeface, right? So you could see how they're going to ask this question as a multiple choice problem. For the next one, it gives us this triangle. It tells us that angle C is the same as angle T, and U is in both of them. So that'll help me redraw the question, right? Before I redraw the triangles, let's label it in the original picture. So it says TU is 4, OU is 5, and OC is 7, which makes CU 12. And it wants us to find the length of ST, so that's X, making SU X plus 4. So if I redraw my triangles, so here we have S, C, U. I know CU is 12, and I know SU is X plus 4. Now, if you made SU just X, you might have to do one step at the end and do some subtracting to find ST. And if I redraw the other triangle with everything pointing in the same direction, right? So I'm going to put T the same place that C was. I'm going to put U the same place U was, and then O is going to be corresponding to S. I can then label my picture accordingly. So TU is 4, OU is 5. So notice I have this set of corresponding segments. By redrawing the question, or the 2 triangles, I can easily see what the corresponding segments are. So now I can say X plus 4 becomes 5 on the same ratio that 12 becomes 4. Do some cross multiplying. I get 4x plus 16 equals 60. 5 times 12, 60. Subtract 16, and I get 4x is equal to 44. Divide by 4, and I get x equals 11. That's it, right? So I could say ST is equal to 11 in this picture. Hopefully this video helped. As you're moving through and studying, you can always remember to rewatch these videos as we keep going here, right? Because the next lesson you'll see, we're going to actually do some algebra, so that should be fun. All right. See you all tomorrow in class. Good luck with your homework.